So in the previous class, I think the demand phase in S before replacement algorithm was given something like this. So look at this. This is the before replacement algorithm. So which was actually given in the previous class here. So where exactly this phase replacement algorithm is required here? Where exactly it is required here in the sense when fourth operation is being success. Third operation is being success, and then fourth operation is going to place that particular frame into the physical memory's free frame. Then this phase replacement algorithm is required. Thereby, we have already discussed about first in first out kind of thing, which is being discussed here. Already it has been done. And for the same kind of reference string, I'd like to go for remaining two which are available. Before going to this, I'd like to give you one specific problem which is being faced by FIFO. That what is that particular problem here? Let me give you. So the problem name is called as Bellides anomaly. Okay, the problem name which is considered as Bellides anomaly. So what is this Bellides anomaly, which is very important question to you, not exactly for your final examination, but it is very, very, very important for you while you are talking something about placement activity. Okay, Bellides anomaly is one of the specific anomaly which is being faced by phase replacement algorithms. So more specifically speaking, the phase replacement algorithm name is what is that name? Is FIFO. What I mean by this particular thing here is when for a specific reference string, let us consider there is a reference string here, whatever the reference string it might be. For a specific reference string, if number of frames are increased, then number of phase faults also increased. Okay, for a particular kind of not exactly particular kind of sometimes FIFO is suffering with this kind of activity here. That activity can be considered as, so if a number of for a particular thing, number of frames will be gets increased to execute that particular process. Number of frames are being executed will be gets increased. Then obviously number of phase faults also gets increased. So that is the particular problem here. This problem was identified Bellides. So that is why it is called as Bellides anomaly. Okay. So for example, if you take one particular set of values here. So let me take, this is the reference string where exactly I do have with me. So reference string will be, for example, 1, 2, so 3, 3, 4. Okay. Then 1, 1, 2, 5. So 1, 2, 3, 4, and 5. These are the reference strings, reference string which is being available with me. Totally number of frames which are being created by this process will be 1 to 5. Totally 5 frames are there. Five pages are there. All these 5 pages are used to complete the particular process here. It will be starts with the first page and ends with fifth page. So that is the general idea about this one here. Now, for example, if your allocated frames by operating system will be 3 frames. For example, 3 frames have been allocated for our process. Then how many number of phase faults will be gets occurred when you are supposed to take into consideration of this one here. Let us consider. So page first frame setup will be drawn by me. Remaining I don't want to draw. You please draw yourselves. మొట్టమొదటి ఒక్కటే నేను డ్రా చేస్తాను, మిగతా అన్ని డ్రా చేయను, మీరు ఒకసారి గుర్తుపెట్టుకోండి ఇది. So that is what I'm saying. So here initially this particular page is not available, one is not available, so it will be considered as a page fault only. So obviously this will becomes under page fault. And the second page also not available with you because your number of frames which have been allocated for you are free. So therefore 1 and 2 will be taken. And the third is also not available with you. So therefore 1, 2, 3. So these three will be obvious for every page replacement algorithm because initially everything is free. Initially everything is free. So that is why all number of frames, how many number of frames are there with you? Obviously those many number of frames page faults will be get suckered. Okay. Then fourth frame is arrived to execute. So by the process here, then what is the frame which is going to replace it here in the sense? So first introduced frame was 1. So that therefore it is being taken something like this here. 1, 2, 4, 2, 3. Then followed by 1 is not available with you. So therefore 4, 1, 3. And 2 is not available with you. So 4, 1, 2. 5 is not available with you. So therefore long back introduced thing will be, so 4 here. So 5, so 1, 2. All these are page faults which are existed with you. Then followed by 1 is when is the next page is 1. Yes, 1 is already existed, no page fault. 2, next page is 2, there is no page fault here. Then 3, so therefore long back introduced the page will be 1. So therefore 5, so 3, 2, this is the next page fault which is available. Then 4, 2 will be replaced here, 2 will be replaced because long back was introduced by 2. So this therefore 5, so let me say 3 and 4 here. 5 is already existed, there is no page fault. So here total number of page faults will be 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 page faults are there as far as so 3 frames have been allocated for our process, for our reference string. Hope that you got this one. Hope that you got this one. Now the same thing will be done with respect to what is it? With respect to 4 frames. Allocated frames by the operating system will be 4. For example, 1, so 2, 3, then followed by 4. So 1, 2, 5. So 1, 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Let us examine 4 frames are there with you. How the things are being gets happened here. Let me draw only for the first one. So here 4 frames are there with you. These are 4 frames which are being allocated by operating system to execute or to complete our process here. So obviously this is page fault only. Everything is free. So first one. So 1, 2, second page fault, and 1, 2, 3, third page fault which is being available. So it is also same. 1, 2, 3, 4. Okay, fourth page fault. 1 is available. 1 is available, so there is no problem. 2 is available, there is no problem. Now 5 is there with you. So 5 doesn't existed within your physical memory. So we need to replace that particular. So any one of these frames, occupied frames with 5 here. So long back introduced. FIFO will suggest to you long back which was introduced, that will be replaced here. So 1 will be replaced with 5. So here it is 2, 1, 3, and then 4. It is also one more page fault. 1 is not available. So 5, 1, 3, 4, and 2 is not available. So 5, 1, 2, 4, and 3 is not available here. So therefore 5, 1, so 2, 3, 4 is not available. So 4. Now most FIFO will be 5 only. 5 or 4. So 1, 2, 3, then 5 is not available. So therefore 4, 5, 2 and 3. You can observe number of phase faults will be, here are 4, 5, 6, 7, 8, 9, 10. So here you can see 10 phase faults. Phase faults. So if you increase the number of frames, allocated frames by the operating system for the same reference string, for same kind of reference string, you got so at 3 allocated frames will be there with you, then it will be 9, whereas it will be 4 allocated frames which are being used to execute your problem, complete your problem. It is 10 phase faults have been occurred here. So this problem is called as Belady's anomaly. To avoid, hope that it is understand by you.
Yes, sir.
If you have
Sir.
any questions, let me answer them. Any questions?
No, sir.
No. Okay. Now, so FIFO is facing such kind of problem here, Belady's anomaly. Because of this particular problem, so 2 more were introduced by scientists. Number 1 is optimal phase replacement algorithm. Optimal phase replacement algorithm. Optimal phase replacement algorithm. What do you mean by optimal phase replacement algorithm here? What exactly this particular thing will be? So this thing will be, so gives you one specific information to you that if your problem which is being executed, whatever the problem which is being executed will be stipulates the number of, will be gives the number of frames in advance. In advance. So these are the number of frames which have been executed. It will be given in advance. Once reference string will be prepared, there is no changes in reference string. Once a reference string will be prepared to execute, to complete a job, there should not have any change in terms of the reference string. If such kind of thing will be so there with you, then optimal phase replacement algorithm is useful. Hope that you got the particular statement I have given here. Optimal phase replacement algorithm can be useful. So for a static so phase reference string. A reference string. So this is the first point you need to consider here. This is the first point you need to consider here. So static phase reference string does means, what do you mean by static here? What is the meaning of this particular static does means here in the sense, once you have to prepare, once you have prepared, not you, a process have prepared, don't write you, once the process have prepared the reference string, there should not any change until its completion. It's process completion. Of course, you have written here process, so completion. Until process completion, you are not supposed to change anymore. Such kind of thing will be called as a static phase replacement, phase reference string here. Once you have to prepare, means once a process will be gets prepared, no other things, no other changes will be happen within the phase replacement, phase reference string here. If such kind of problems are there with you for execution, then optimal phase replacement is so useful for you. As the name suggests, optimal, which will be gives you very less number of page faults. Very less number of page faults. So OPR in the sense optimal page replacement algorithm. Please write in a form in a full form. I am writing OPRA. So is gives very less page faults. Page faults. Okay, why it has been provided very less page faults, and what are the advantages over FIFO? Okay, we are supposed to talk two different issues. Why it will be produces so very less page faults? What are the advantages of? I mean, what is the overcome of advantages overcome of FIFO here? So look at this. I'll scroll up to FIFO here. Okay, let me go for this particular area. Three allocated frames. You can see. So as far as this particular problem, probably here it is not there. This is actually for Berard's anomaly. So let me open this one here. Previous question here. Previously discussed something here. You can see here. You can see this particular area. Let me copy this one. Was it copied? Should it copy? Okay, let me open in terms of using Paint, MS Paint, then it will be very easy to discuss. Open with Paint. Okay, you can see this one. As far as this particular thing, you can see this is obvious. This kind of thing is obvious. This is also obvious. This is also obvious because all these three are obvious. You can see 2 was just available here, which was replaced by 7. Okay, it is very good. As far as FIFO, I'm talking. As far as FIFO, I'm talking. 2 was replaced. Okay. Now, 0 is there with you, next reference string, the next frame which is going to load is 0. 0 is already available. 0 is already available. 0 is already available. While replacing just before used will not be replaced. Okay, that is one cause, not exactly for optimal. It is not exactly for optimal. I am talking about pitfalls or problems with FIFO. I am not talking about optimal. I am talking about the problem which is raised by FIFO. Because of this particular reason only Berard's anomaly was raised. Okay, so that is what I am trying to speak something here. So 0 was just before used, so which is already existed, but when new kind of frame is available, since it is available at the 3 to 4 frames ago, so that is why it was replaced here. So if you are not supposed to replace this one, since it was used just before, 0 were used just before here at this place. Because of 0, there is no page fault. Page fault is not existed. So why you are supposed to replace this particular thing by 0? Does it not possible to replace with by 1? So if you do so, then there might be having some kind of advantage over FIFO. This is one particular point. Hope that you understand.
Yes, sir.
Yes, sir.
Yes. 2 more.
Yes, sir.
Then
Yes, sir.
okay. Then here, so this is one particular problem in FIFO. Then while replacing a particular frame, why you are not supposed to look? Because already in optimal we told that this reference string is a static string. Entire reference string is there with you. Entire reference string is there with you. So therefore, why you are not supposed to consider this particular static string, okay? Why you are not supposed to consider this one, and why your replacement will not done? So in terms of a future approach, okay? What do you mean by that? What do you mean by that? Future approach does means you can see 7 is the particular frame which is not supposed to use till end. You can say this one here. Till end, it is not been used. So while replacing, you please replace with that. So that is the point what I made. Okay, if it is okay, if it is, I mean, this particular thing was replaced in a proper way by, so first in, first out, there is no problem at all. But while replacing next, 0 is already available. While replacing 3 with other things, you please concentrate, which frame is not supposed to use for longer period of time. For longer period of time, you can see 3 must be replaced with either of 2, 0, 1. Either of these 2, 0, 1 you have to replace. You can see 2 can be useful very shortly. 0 can used immediately after 3. If you observe 1 was used very after long time. After long time it has been used. So replace with this. Replace with this particular thing. Therefore, your time will be get saved, and all the let me say all different kinds of frames which are available between 3 and 1 will be available with you. So therefore, the number of page faults will be reduced. Hope that you got the point. You got the point. Let me write this statement here. Before going to write the statement, I hope that you do understand what I'm speaking.
Yes, sir.
Remaining 3.
Yes, sir. Sir.
So let me write the statement here. What is that particular statement which I'd like to quote here is, so those are the two problems with FIFO. So to satisfy this particular thing, how the things are going to be gets happen here in the sense, this is the way. So look at this optimal page replacement algorithm can be done something like this here. So this is the way. So look at this. Replace the page. Replace the page. Okay. That will not be used for the not FOR for the longest period of time. The longest period of time. Longest period of time in the sense. So what do you mean by this longest period of time? What do you mean by this particular longest period here in the sense? You must always looking towards a forward direction. Forward direction. Why you are supposed to look into forward direction here in the sense? Already in optimal page replacement algorithm, I have already we have already discussed something about it is a static page reference string has been provided. Since it is a static page reference string has been provided because of this particular reason. What do you mean by static page reference string in the sense? It should not be changed. Once it has been prepared, these are the pages which are going to be loaded and executed. This is the order in the sense there is no change in it. Until completion of that particular process, there is no change. Because of not having any change, so therefore in forward direction, for longest period of time in forward direction, which is not supposed to be used, that is going to be replaced. That is going to be replaced. So that is what the point I'd like to make here. So for to satisfy this particular thing, I'd like to copy the same string here. I'd like to copy the same string here, 701, something like this. I'd like to copy the same. Because for explanation point of view, I don't want to so take much time to do this particular thing here again. So Okay, so let us examine three frames are being allocated for our process. Then how the things are being gets happen while the three frames will be took place here. Then let me discuss with that particular thing how optimal phase replacement algorithm can be so works for you here. So let me draw for only the first one, and remaining everything is obvious. Please write by you. So something like this. Let me read out the frames: 701, 203, 042, 030, 212, 01701. These are the frames. These are the frames here to complete your process. Now let me talk something about let me draw only for the first time. I'd like to draw for so this one here because it is time killing process. So 7 will be not available, so it could be replaced. This is obvious. And 701, it is also obvious. Sorry, one is not there, sorry. So 701, these three page replacements are obvious because initially your allocated frames are three and three are empty, so they can be. Now, so replacement will be done with two by which kind of so what is that frame here or page here? So here, as far as in so reference string, we are considering that this reference string is a static string, and 7 is not supposed to use for longer period of time. So 7 was being used here at a longer period of time. So therefore, this is not supposed to be used. So therefore, you just so replace your 2 with 7. So 201. There is no change in FIFO on this one because same reference string. There is no change at all. And 0, trying to replace this particular 0 because 0 is available with you or not. Yes, 0 is available. No more changes here. No page fault here. Now 3, I would like to replace any one of these frames with 3. Which one it is going to be taken here in the sense? So 201 out of these three frames. So you can examine until, I mean, you can walk through this entire string. Which one is a very longer period of time not supposed to use by the process. So here for longer period of time, so 2 was used after some time, 0 was used immediately after 3, but 1 is a longer period of time is supposed to be taken. So I'd like to replace with 1 here. So therefore, so here it is 2, 0, 3. Now 0 is already available. 0 is already available. Now 4 is not available. With which kind of a thing I would like to replace here? You can observe 2 and 3. After 4, immediately 3 is there. After 2, immediately 3 is available. So after that, if you consider in the forward direction, if you consider 0 will be used after 2 different frames. Those frames are 2 and 3. So therefore, you have to replace with this particular 0 by this one here. So therefore, 2, 4, 3. Okay. Then 2 is already available. Then 3 is already available. 2 is already available. 3 is already available. 0 can be replaced with which kind of thing here? So you can see out of 2, 3, 4, you never find 4 here. Within this particular reference string, there is no 4. So you can replace with 4. So 2, 0, 3. 3 is available here. 2 is available here. Then now time will comes to replace with 1. Which one is going to be replaced here? You can observe after 1, so 3 never available here. So because of not having 3, you can replace with 2, 0, 1. It is going to be replaced. Now 2 is okay, then 0 is okay, then 1 also be okay. Then here, wanted to replace with 7. So after this particular thing, 2 is never available within the reference string. So 7, so 0 and 1. Of course, 0 is there, 1 is there. You can 1, 2, 3, 4, 5, 6, 7, 8, 9. Totally, previously we got, I think it is 15. Now it is, we got, previously it is 14. Now it is got 9 page faults only. phase faults only. It is very good algorithm, it is very good algorithm, but there is a problem. There is a specific problem. What is that problem here? The problem is lies with this static phase reference string. This is the problem. If real-time operating system is being running, things will not be done with the passive static phase reference string. It must be dynamic. It must be dynamic. We don't know which page will be comes and joined to this tail of the queue. It is actually a linked list. Actually, this is the entire thing will be a linked list. We don't know which is going to join. For example, after some time, 6 is going to be joined. After some time, 1 is going to join. After some time, so something is going to join, because we don't know so which page will be gets joined if it is real time application. So that is why if it is static, there is no problem. If it is static, there is no problem. If it is real time, optimal page replacement algorithm cannot be supported. Okay, this is what about optimal page replacement algorithm. And if you are talking something about this particular thing, does optimal page replacement algorithm is suffering with Bell-Davis anomaly or not? Let us check. It never ever suffered. So Bell-Davis anomaly does means this one. So let me take 1, 2, 3, and 4, followed by 1, 2, 5, 1, 2, 3, 4, and 5. This is the reference string to be processed for Bell-Davis anomaly. Let me draw. Initially, I don't want to draw here. Please consider me. 1 is not available. So 1, 2, not available. So 1, 2, 3. These 3 are intuitive. These 3 are intuitive. You must always get in this one here. Now 1, 2, 3. Out of 1, 2, 3, which one is going to be replaced here? So 4 will be replaced with out of 1, 2, 3. Which one? So you can see 3 is used after very long time. So therefore, 1, 2, 4. 1 is available, 2 is available. Now, so 5 replace with which page? So here 4 is available after very long time in forward direction in future. So therefore 1, 2, 5. 1 is available, 2 is available, there is no problem at all. And 3, which is going to be replaced with. So 1 and 2 are not available after 3. So therefore you can take FCFS here, FIFO here. So I'd like to replace with 3, 2, 5. And obviously, so 3, 4, 5. Obviously, things are gets over. So how many? 3 plus 1, 4, 5, 6, and 7. 7 phase replacement, phase faults are existed. Whereas for the same, if 4 frames will be taken, 1, 2, 3, 4, 1, 2, 5, 1, 2, 3, 4, and 5. To take the same for FCFS, చెప్పారుగా FCFS, first come first serve based, ఎక్కడైనా చేసుకో. Okay, any one of them. So his doubt is why you have replaced with 1, why it is not 2. So that's what I have told you. It is FCFS, first come first serve. So it has been replaced here, then 4 will be replaced here. Okay, na? Now here 4 frames will be gets allocated. Then if 4 frames will be there, obviously your problem will be seems 1, and here it is 1, 2, and here it is 1, 2, 3, and here it is 1, 2, 3, and 4. Up to this one common, because 4 are free frames here, so there is no option. 4 phase faults are common. 1 is already available, 2 is already available. If you take 5, with which kind of thing is it is going to be replaced here in the sense? Shall I know from you? 5 will be replaced with which frame?
4, sir.
4, because 4 is being used at the last longer period of time. So therefore 1, 2, 3, and 5. 1 is available, 2 is available, 4 is available, 3 is available. Then you can replace which one by using 1, 2, 3, 4, 1, 2, 3, 5 here. So FCFS here also FCFS, because FCFS. 1 is not available, 2 is not available, 3 is not available after 4. So you can go for FCFS. So here it is 4, 2, 3, and 5. You can see 5 is already available. 4 plus 2, total is 6. Belady's anomaly in the sense, if number of frames are being increased, phase faults also increased. That is Belady's anomaly. You can see this particular thing, it is not suffering with the Belady's anomaly. There is no problem with optimal. There is no problem with optimal. So therefore, optimal can be useful for you. But there is a condition. What is that condition here in the sense? This is the condition. Static. I'm always pointing about this one here. Static. Static phase reference string can be provided to your operating system. Then optimal is very good enough. Very, very, very good enough. Okay. So that is what the optimal phase replacement algorithm. It is not supposed to be suffered with Belady's anomaly, and being provided very good phase replacement algorithm. So for the same string which was given by the previous FIFO, which is 14 different kinds of phase faults have been occurred, but here you got only 9. Okay, so it is very good. So time is running out, then we'll move to some other after 10 minutes. I hope that there is a question. What is that question? No, Belady's anomaly cannot be common for all phase replacement algorithms because FIFO is being suffering with the Belady's anomaly. FIFO is suffering with the Belady's anomaly. Then to avoid that Belady's anomaly, so optimal and LRU was introduced. It has been avoided. It has been completely avoided. So therefore, so Belady's anomaly cannot be there. Belady's anomaly is available with only FIFO. Okay. So that's what this class. So we are running out of time. Just only some 30 to 35 seconds are left over. I'm closing this one, and I'll come back within 10 minutes. Are you ready to come?
Yes, sir.